Welcome out to DatMan 3. In this update, we thought we'd try our hand at overlaying an S3D2 pattern over the ancient and ubiquitous GNU DBM, or database management technology. A little background information here. We've had DBM technology out there for a while. And unlike when we are using our JSON format for storing our tags and values, the GNU DBM has a very distinct format with several key advantages. First, as we have seen when we are using VS Code, we are doing nothing more or less than associating L values or something on the left with an R value or something on the right. And we can think of that once again as being a tag, value, or a key value combination, as we're very familiar with our Python dictionaries. Given the fact that we're limited to a left value and a right value, however, isn't much of a limitation as long as, of course, our keys or our L values are always unique and the concept is easy enough to understand. What you might find a little difficult to understand is the key advantages of the DBM format, because unlike when we're using JSON to accomplish much the same thing, we don't have to read the entire database into memory. When we're using the DBM technology or concepts, what we're doing is actually searching data on our hard drive without using integral constants, as I talk about in my Python 3000 file IO, but instead simply using the key or the tag to find our information. Another key difference is, of course, we have the ability to update our information based upon a maximum size of the information that we wish to have on our hard drive. Traditionally, that size has been user-defined, and when it's not defined, it defaults to the size of our sectors on the hard drive. Once again, I said these were advanced lessons. And the sectors on the hard drives are typically multiples of 512, 4096 being common, 8K being even more common on servers. And if you're unfamiliar with hard drive sectors, inodes, and whatnot, I'll commend you to my other training, specifically my Python 4000 DevOps. We talk about the layout of many hard drives. The bottom line here, however, is that we have a file format that, like a bunch of shoe boxes of the same size, will allow us to put things into that box and then look for that information by key, as well as update the information so as to use what's ever left in the shoe box, or of course span multiple shoe boxes based upon the size of our data. Looking at the code, I've kind of gone crazy with the regional tags. I do like the regional tag. Maybe at some point in time we'll have an equivalent capability in Python. In this case, I have the meta area where I have my file information, my license information, file name, etc. But of course, the region, once again, only available in Visual Studio or Microsoft products at the time of this recording, allows us to delineate between our three areas that we're going to want to be talking about for this discussion. The internals, of course, were used so as to maximize the ability to use a DBM technology. Oftentimes we'll call this a low-level driver, and we're not going to talk too much about that because the code is available on GitHub, and you can take a look at it. The public interface, as we were mapping the S3D2 pattern, wound up having to have a count, and I put the count in later on, simply because I was using the search capability with a lambda that would take a key and a value so as to give me the count of what was going on. Not a very efficient way of doing business, but my personal preference is that whenever something uses the public interface, of course, we would try to make that public if it makes sense, and that's what we did here. Everything else works the way you'd expect with our source, simply returning our key value pair, which we set up. It's never going to change. DBM technology simply has a key and a value. But looking at our constructor, we'll see that that key and a value just arbitrarily was put together in a dictionary with the tags being, oddly enough, key and value. So whenever we source something, we're simply going to get a dictionary back with the key equal to a string and a value equal to a string. And we can put more information in there and enumerate the keys. It's pretty flexible in that regard. But in the DBM technology, we really are talking about associating a left and a right, or a key and a value pair. Our test cases work pretty much as you'd expect. We have this capability of using the region now so as to leave our outside areas to talk about which case we want to take a look at. And whenever I'm testing in Visual Studio, of course, I do follow this pattern, keeps the clutter down. And once again, maybe we'll get a pep out of this at some point in time. Really a cool feature from Microsoft. And oddly enough, I think it's something they actually originated themselves rather than being, quote, inspired by some other people. Calling your attention to the repopulation test case just to show how this works. Another cool feature of using DBM is that we're able to, unlike you might see in JSON, at least without a lot of effort on our part, is the ability to embed new lines and have those new lines and spaces come out verbatim, which of course can happen, but is relatively effortless for us to embed into our records whenever you're using the DBM format. And we'll see this in the SQL lessons that I'll be putting out shortly here to use the S3D2 pattern as well. And here again, rather than going through each and every one of our test cases, anybody interested can go ahead and look at this project up on GitHub, which, going back to our metadata, is available in our related location. Hope you enjoyed the video, and I'm looking forward to seeing you in the professional data management world.